lot of high school students suffer with this topic, implicit differentiation. Honestly, it's not that deep. Let's get started. So suppose we have an expression given that x squared plus y squared is equal to 25. Immediately, we can tell that this is an equation of a circle, and we're being told to find dy over dx, meaning that the expression for the gradient of the circle at any given point x. So let's go ahead and find dy over dx. But first, we want to sketch the graph of the circle. And so suppose we want to find the gradient of the circle at point, say, 3, 4. And so if we had a tangent line that would cross across this point, which would look something like this, the gradient of this tangent line will be the gradient of the function at that given point. So essentially, we're going to be finding the gradient of that tangent line. So let's go ahead and find dy over dx from this equation we have. To do this, we're going to differentiate both the left-hand side and the right-hand side with respect to x. So d over dx, x squared plus y squared, is equal to d over dx, 25. Now when we differentiate x squared with respect to x, it's simply going to be 2x by using the power rule. So we write 2x, and now to differentiate y squared with respect to x, we'll have to use the chain rule, because y is a function that is also composed of x, right? It's directly not x, so we can't really differentiate it that way. Now, the chain rule states that if you've got a function y, which is also composed of another function of x, then to differentiate the entire function, you'd first differentiate y by using the power rule, and you'd multiply that by the derivative of the function that y is composed of. So at first we're going to find the derivative of y. We're just going to do it usually as a power rule, which comes across as 2y. And then we would have to multiply it by dy over dx, which is the derivative of the function that y is composed of. And then this would equal to 0, since the derivative of 25 is 0, since it's a constant. Next, we take this expression, then we solve for dy over dx, and this is simple algebra. So 2y times dy over dx is equal to minus 2x, then dy over dx becomes minus 2x over 2y, and finally dy over dx becomes minus x over y. And this is our dy over dx. And dy over dx basically tells us that put in any x and y value that exists in our circle, and it will generate the gradient of the tangent that passes through that point.